When creating a visualization in Unreal, we may want to light a building exterior or interior, a product, or even a design element using a real-world environment, possibly a very specific real-world location, which in Unreal means making use of high dynamic range images to light our scene, creating a GI solution that then has lots of subtle lighting variations built in by default. To help do that, we have our O2_O2 level loaded, which has had all of the lights deleted from the level, and the environment intensity setting in the light mask controls turned down to 0, meaning we are now in complete darkness. The light mask settings have been adjusted so as to give us a good GI result when using a skylight, so a skylight bounce value of 10, as well as the adjusted quality and smoothness settings that we have already looked at. We also have a light portal set up in the window opening, which will be vital in a level where no direct light is going to be applied. Let's come to the mode section of our UI then, and in the search field, type sky. After which we can click and drag to add a new skylight to the scene, and press G to make sure that we are viewing things using the game lighting mode. Let's also make sure that our skylight is set to static. Now this will possibly be one of the easiest lighting solutions that we will ever create, as all we need to do now is select our cube map of choice, which I've downloaded under a Creative Commons license from the HDRI-hub.com website that allows us to also distribute the HDRI, which we can see right here in the content browser. Making sure that we have our skylight selected, we can change the source type to SLS specified cube map. After which we can click and drag on our HDRI in order to place it in the cube map slot. Meaning it is time to rebuild our lighting and take a look at the results. As you can see, we are getting some lighting in the scene, but nowhere near a level that would make us think that we are looking at a bright sunny outdoor scene, which is what the HDRI depicts. Let's crank things up then, setting the intensity of our skylight to a value of 10. Which will work by increasing the intensity of the HDRI that is mapped to it. And after rebaking our lighting, we can see that we have added a good amount of energy and detail to our lighting now. We could also increase our cube map resolution if we wanted, so as to get more quality from the setup. Although just remember that this has to be done using power of 2 values. And we do need to be cautious when upping the resolution, as this will, of course, increase our build times as well. We also need to keep in mind that it's no good increasing the HDRI's resolution if our light map resolution is left too small on our static meshes, as all of the settings that we have looked at so far in the course really do need to work together in a balanced way. Let's set our cube map to a high value of 512 then, and see if that makes any noticeable difference to the quality of our GI lighting. Once the lighting has baked, we can compare the results, and then make a decision as to whether or not the added bake time versus the quality improvement that we see has been worth it or not. Something that we could do then is lower the quality settings of the GI in the light mask controls, and then also increase the smoothing value back up to 1, as our skylight is now doing most of the work when it comes to picking out details in the scene. When we rebuild our lighting now, we see that we do indeed have a pretty decent GI solution, and once the scene is textured and the user is moving around, of course, any small problems that may still exist within the solution would most likely be unnoticeable.